Michelle.
How many decimals do we?
Hmm.
Do you go?
I do 3. Yeah, the point something something something.
Yeah.
I think that'll be because some of those gonna be pretty small. Yeah. So let the bottom. Yeah. So you guys got the decimals? Yes. What do we got for this? 0.036. How's that sound? Yes.
Yes.
Beautiful. How about 30 out of 221? Maybe 12, 13%?
0.136.
137?
13.6.
Say that again.
0.136.
Oh, thank you. And yeah, if you guys want to go with percentages, just move a 2 over and call it a percentage, right? 3.6%, 13 points. That's what you were saying.
Yeah.
Brittany, thank you, thank you, thank you. 79 out of 221?
0.35.
357? Love it. 67? 303? 35? About half of that, right? 158? And if I was clever and could do math quickly, I could figure the last one out, couldn't I? Anybody think of how I could figure it without actually doing the division? How could I figure the last one out very, very rapidly? What do these have to add up to? Yes! They'd have to sum up to 1, yes? So if I could add really quickly in my head, I could add these up and figure out what's left to get to 100. I cannot, so therefore I'm going to have you guys tell me with just about under 1%, 0.00. 0, thank you. Just because that's 2 and 221. 2 and 200 would be exactly 1%. So that's going to be a little bit less. All right. Now, the question I have for you guys is, and I want to connect this into your last project, because it's all connected. All this stuff is connected. It doesn't seem like that when you're sitting at home trying to do my projects, how it's all connected. This is one of your project questions from your last project. The student who's guessing at a 5-question true-false test. Now this is x equals number of heads, but it could just as easily be x equals the number of questions the student gets right. Because if they guess, they might not get any of them right. They might get them all right. They might get 1 right and 4 wrong, 4 right and 1 wrong, or 2 right and 3 wrong, and vice versa. So how many outcomes are there total for this experiment? This will also help you with that question on your exam.
6.
If you're guessing, no, okay, I like what you're saying here. But as far as once the student has guessed all 5 questions, how many different combinations of right and wrong are there? Or how many different sequences of heads and tails are there? For example, 0, how many ways can you get 0 heads? 1 way. You go tails, 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 tails. So theoretically speaking, there should only be 1 way of getting this out of how many outcomes? And here's the question. We ran the trial 221 times, but there really are only how many outcomes discretely of the trial? 32. Remember the number 32 from your project? There are 32 outcomes. Why? 2 times 2 times 2 times 2 times 2. It becomes that. It's the question we started the day with. Is 2 to the 5th power. There are 32 outcomes. We'll come back to that as a decimal in a second. It looks like this one. It's close to this one. It's not perfect. It's close. Let's go to... Wait, answer that question, Winnie.
I spaced off.
Oh, the 32?
Yeah.
Think of it like this. Think of your tree diagram from your last project.
Yeah.
First flip, 2 branches. Next flip, 4 branches. Next flip, 8 branches.
Okay.
What's the pattern? 2, 4, 8. What's going to happen next? How many branches now? That's a lot of branches. 16. And if you double again, it gets to 32. Does that make, so each time you flip 1 more time, you're doubling the... This is why as a mountain biker, I get very excited in the woods. Whenever I find a new trail that splits. Because I say to myself, hot damn, I just double the number of trails I know. Because I do, right? I do all the trails I know now go left, and all the trails I now know go right. That's double the number of trails I had before. Yeah, quite a slight design, that's okay. But that's the thing, every time you have a choice that splits, you've doubled the number of whatever you have. Okay, forget the trails. How about getting 1 H and 4 T's? Now, it's still out of 32, yes? There's 32 possibilities for that. There's still 32 possibilities for flipping the coin 5 times. But how many of them have 1 head and 4 tails?
10.
I gotta go for 10.
Oh, 1, 4. And 4 tails?
4 tails, 1 head. Faith, what are you thinking?
5.
I hear Randall,
Each slot has an option to be,
good.
have one.
So what Faith is saying is, this is why I really wish Excel was working. I have a nice simulation to show you all this. So for no heads, it was pretty easy to fill them in, right? We just went tails, 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 and we're done. Yes, we're finished. Finished. For 1 head and 4 tails, we still have to fill the outcomes out. Yes. So give me one, Faith.
Tails, head, 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 head.
Well, it was only 1 head though. So how about tails, heads, tails, tails, tails?
Yes. And then tails, tails, head, tails, tails.
So you're saying this is 1. We could also put the heads here.
And then you can put it at the end. You can put it one more over.
Slow down.
And you can put it at the very beginning.
Did everybody keep track of that?
That's it.
How many was that?
5.
5.
Was that 5? So in other words, what you're saying is the head could go there, or it 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 could go there. So there's 5 ways for it to happen. Oh, okay, I'll buy that. 5 and 32. You buy that logic?
Yeah.
Is that fair? That was a little hard with the erasing. I apologize. I should be keeping up more quickly.
I was saying it's back.
No, you weren't. Not at all. Okay, you ready? 2 heads, 3 tails. How many ways can that happen? 3? No, I'm just hearing noises. I'm sorry.
No, I'm here.
3. You hearing 3?
Okay.
10. What's 10 and 3's average? 6.5. Can't do that. Well, let's figure it out. Let's figure it out. These are the heads right here. My fingers are the heads. 4. Here we go. Here we go. Ready?
1, 2, 3, 4.
So there's 4 ways so that the first one is also a heads. But the first one doesn't have to be heads, right? It could be the second one's a heads, yeah? Now watch what I'm not going to do. I'm not going to count this one again because I already counted that one the first time. So I got 1, 2, 3, 4.
5, 6, 7, 8, 9, 10.
10.
Oh
Boom!
my gosh.
10 ways. Slick. Slick. This is, by the way, this is what you guys had to do in your project, right? You had to write them all out. We're just doing it in a more efficient way now. That's the point. Once you know how the math, underlying math works, you can do it this way much more efficiently. So it's 10 in 32. Oh, yes. How about 3 heads, 2 tails?
6.
6. 15. 20. 30. Okay, well, careful now. Hang on.
49.
We know, what does this have to add up to?
32.
32 out of 32, right? It has to add up. Who said 1? I love that, by the way, whoever said 1. Yes. It has to be 1, just like the other one is 1. The probabilities, that whether they're percentages or fractions, have to add up to 100%. So, oh, I should be over here, I'm sorry. See both sides. So this obviously couldn't be 30 out of 32, because that would push us over 1, right? Okay. So, what about just figure it out? Now, you might think to yourself, that means you have to have 3 fingers, right? I mean, technically, I need 3 heads, so I need 3 fingers. But we'll say, no, why don't you be efficient and instead of counting the 3 heads, count the 2 tails?
Oh, so just be 5.
It would just be what?
5.
Wouldn't it just be 10 again? Because if I'm only counting the 2 tails, I'm going to use 2 fingers, and that was like I just did for this one. Now, some of you are saying, to hell with that, use your 3 fingers. Okay, let's do that.
Yeah, because I'm...
Okay, you ready? Here we go. Actually, can I get some help? I'll do 2 pointer fingers. Randall, come here. 2 pointer fingers. You moved. That was your mistake.
I'm sorry.
You moved. It was your mistake. I'm going to move the camera a little bit. Okay, so I'm going to start by putting these in the first 2 spots. You guys keep track. So Randall, there's 1, 2, 3, yeah? Now I'm going to move this guy over. Where can yours go? Good. You see what he did? He started coming back over here and then stopped because we already counted that one, didn't we? So let's go back to the beginning. Back to the beginning. 1. You guys count.
2,
Okay?
3, 4, 5.
Okay. Now, this guy's got to move, yeah? Because he doesn't have to be in the front. He could be here. Yes? Did we count that one already? I don't think so. 8, 9,
10.
boom. Done. 10. The other ones are the tails. So there's 10 ways to do that as well. Pretty slick. Ah. No. All you're doing is your project again. If you look at your project, have your project open in front of you right now, and you can go find all of these. You will see that of those 32 outcomes, one of them has all tails. 5 of them have one H, and well, I guess you did correct and wrong, didn't you? Not heads and tails, but it's the same thing. One of them is all correct. One of them is 4 correct, 1 wrong. Or excuse me, 5 of them are 4 correct, 1 wrong. 10 of them are 3 correct, 2 wrong. 10 more of them are 2 correct, 3 wrong. How many are going to be in here? 5 again. Now think about why. Think about why. If you got 4 heads, there's 1 little tail floating around. And he can land in any of those 5 spots. So it's going to be 5 out of 32. And last but not least, how about all heads? Now what are these as fractions? Let's see. This is going to be, hang on.
0.031.
Thank you. I was going to say it's about 3%. And so is this one, because it's the same, right?
Right.
Which means this one is 10 times that, so that's 31%, right? 3-1.
0.312. Yeah.
Excellent. Thank you, Michelle. And this one is 0.155?
0.156.
Yep.
Excellent. Look how close those came to what you guys got. Pretty slick. Pretty slick. Is it random that they matched you guys so well? Yeah, kinda. But it's also cool. It's also predictable. Since you're flipping coins and the coins are essentially random, some of you are getting 5 heads. So a couple of you got 5 heads, yes? That's a very rare event. It only happens, it should happen 3% of the time. Well, we only saw it. We saw it a little less than that. But it shouldn't happen as much as these guys in the middle happen. So what you saw was, you guys saw a representation of what should have happened with randomness. It's exactly, you guys saw exactly what you should have seen. Exactly what you should have seen. Are you seeing the connection between this and your project? Hopefully, maybe-ish. If you look at those outcomes, those 32 outcomes in your project, you will see all of those in there. That's what's so slick about it. That's what's so slick about it. And again, if you're gambling with coins, this is known. These things are known. I bring this one up. The reason I brought this one back from the grave was because, remember, about 2 weeks ago, I asked you guys to, on the board I asked you to write down 5 random heads and tails. Everybody did a pretty good job of putting this correctly on the board. You also did a fairly good job of putting these correctly on the board, but almost nobody put these on the board. I don't know why. I don't know why. So in other words, these percentages were almost perfect. These were a smidge high and these were too low. Why? I have no idea. I don't know why, but this is the percentages they should have shown up in. So I always promised myself to get back to this one. Get back to this one. Here's a question for you. On average, how many heads do you get out of every 5 flips of a coin? On average. If you had to bet, if you could bet on averages, which you can't in a casino, because you could bet on averages, they would kick you out. But if you had to bet on average, what's the most? Go ahead, Faith. You would say 3. Who would say 2? A couple 2s? 3s? What if I allowed you to pick numbers between numbers? I have to allow you to do that, don't I? Because the average is actually 2.5. I'm getting into 243 a little bit here, Terry. I apologize. It is 2.5. It's directly in the middle because this thing is exactly symmetric. See how 1 plus 5 plus 10 is 16 and 32? 10 plus 5 plus 1 is the other 16 and 32? The average is right between at 2.5. Exactly. Now some of you say, you can't average 2.5. And I say, sure you can. You totally can average 2.5. You just can't roll 2.5. But what that means is, for every time you roll 2, you roll a 3. For every time you roll 4, you roll a 1, and for every time you roll 0, you roll a 5, and it all washes out and becomes 2.5. Does that make sense? Is that believable? All right. So that is just once more a beautiful kind of illustration of practice leading into theory, leading back to practice. The trick, though, is, for craps, we have to know what it's like when we're rolling a pair of dice. So the last thing I want to do today is I want to establish I want to establish what Vegas already knows, which is when you throw a pair of dice, what happens. So when you play craps, take a pair of dice. When you play craps, what you're betting on is the sum of the numbers that show when you roll the dice. So when you throw the dice, 2 numbers show up, you add them together, and that's your bet. There are other ways to bet in craps, but I want to keep it simple at first. I want to keep it to the normal, what's called a pass line bet. And we'll talk about that on Wednesday as far as the rules of betting pass line. What I want to do right now, though, is I want to make sure we understand this for a pair of dice. Because if you understand this, you understand the game. Otherwise, the game is just, is he giving me money? Is he taking my money? Chances are he's taking your money. But at least you understand why and how much and how often. So, let's build this for a pair of dice as well. So you don't have